Blue-tongued skink. There's a lizard in Australia that doesn't run when cornered. Instead, it opens its mouth. And inside is something that, honestly, just shouldn't exist. A tongue so blue it looks painted. The blue-tongued skink is a medium-sized reptile found across Australia and parts of Indonesia. When a predator approaches, the skink faces the threat and reveals that impossible blue. The reaction is immediate. The predator stops. Not because the tongue is dangerous. There's no venom, just color. But the predator's brain doesn't know that. In nature, bright, unusual colors often signal poison. And in that single moment of hesitation, the skink escapes. It's a bluff refined over millions of years. What really makes it work is the unexpectedness. Predators just don't anticipate blue inside a reptile's mouth. Blue-tongued skinks give birth to live young. The babies arrive already equipped with the same brilliant tongue. The deception is inherited. A newborn skink has never seen a predator, but it already knows how to lie to one. Thorny devil. In the Australian desert, water doesn't fall from the sky often enough to rely on, so the thorny devil doesn't rely on it. This small lizard has skin covered entirely in sharp spines. Between each spine runs a microscopic groove. When dew forms at night or rain touches the lizard's body, water doesn't just sit there, it moves. The grooves pull moisture through capillary action directly toward the lizard's mouth. The thorny devil drinks through its skin. It doesn't need to find water. It collects it passively while staying completely still. This solves a problem most animals can't. The thorny devil eats only ants. Thousands every day, consumed one at a time with mechanical precision. It walks with a jerky gait that makes it look like wind-blown debris. Predators scan for smooth movement. Anything that moves like the thorny devil doesn't register as alive. On its neck sits a false head. When threatened, the lizard tucks its real head down and presents the decoy. Panther chameleon. Color in nature usually serves a purpose, but the panther chameleon takes it further. This large chameleon is native to Madagascar, and males are among the most colorful reptiles on Earth. Red, green, blue, orange, yellow. The exact combination depends on where the chameleon lives. Each region produces its own distinct pattern, like dialects written in color. Panther chameleons have eyes that move independently. One can look forward while the other scans behind. They hunt insects using a tongue that extends to twice their body length. The strike happens in less than a second. Males are territorial. Bright colors communicate dominance, stress, and intent. A male displaying full color is announcing ownership. Breeders have intensified certain traits over generations. Captive-bred chameleons are often more vivid than wild counterparts. Females can store sperm and produce multiple clutches from a single mating. They lay eggs buried in soil. The eggs take 6 to 9 months to hatch. By the time offspring emerge, the landscape may have changed entirely. Armadillo-girdled lizard. Defense takes many forms. The armadillo-girdled lizard does something unique. When threatened, it curls into a ball and bites its own tail. The result is a near-perfect ring of spiny scales. Predators can't get a grip. They can't pry it open. Eventually, most give up. This small lizard is found in rocky outcrops of South Africa. They live in crevices and are surprisingly social. Most lizards are solitary, but these form small family groups. They communicate through body language, head bobs, push-ups, subtle signals that maintain hierarchy without violence. These lizards don't lay eggs. Females give birth to 1 or 2 live young per year. The babies are well developed and independent immediately. Their scales are heavily keeled, arranged in tight rows. The texture alone deters many predators. In the wild, they can live up to 25 years. That's unusually long for a lizard this size, which suggests their defensive strategy works consistently. There's a moment when stillness breaks into chaos. The frilled lizard lives for that moment. Found in northern Australia and New Guinea, this reptile spends most of its time motionless in trees. But, when threatened, everything changes. The lizard opens its mouth wide and a massive frill unfolds around its neck. The frill can reach 4 times the body's width. It's theatrical. Shocking. Most predators hesitate. If the display doesn't work, the lizard runs. Not on 4 legs. It rises onto its hind legs and sprints, tail whipping for balance. It's one of the few lizards capable of sustained bipedal movement. The frill is supported by cartilaginous rods connected to the jaw. When the mouth opens, the frill extends automatically. It's mechanical, built into the structure. Fear triggers the jaw. The jaw triggers the frill. Suddenly, a small reptile looks 3 times its actual size. Despite the dramatic display, they're not aggressive. No reptile should be able to do what the marine iguana does. Reptiles are cold-blooded. The ocean is cold. Cold blood in cold water means shutdown. And yet, the marine iguana dives. Found only on the Galapagos Islands, it dives up to 30 feet, holding its breath for over 30 minutes, grazing on algae on submerged rocks. The water is often 10 to 15 degrees colder than the iguana's body. Every second drains heat. When it surfaces, it's sluggish, vulnerable, so it drags itself onto black volcanic rock and basks. The dark skin absorbs heat quickly, but recovery takes time. The entire cycle is a negotiation with physics. Long claws grip slippery rocks. A flattened tail propels through water. Specialized salt glands expel excess sodium, causing constant sneezing. During El Niño years, ocean temperatures rise, algae dies, and iguanas starve. Their bodies actually shrink. They lose bone mass to conserve energy. The marine iguana hasn't just adapted to the ocean, it's become dependent on it. The Gila monster is venomous, but venom isn't why it survives. This lizard moves slowly, almost lethargically. It spends most time underground in burrows where temperature stays survivable. When it emerges, it's to find food, bird eggs, nestlings, small mammals, but food is rare. Sometimes weeks pass between meals. The Gila monster stores fat in its thick tail. That reserve sustains it for months. The tail is a calendar, a visual record of the last meal. When thick, the lizard can wait. When it thins, survival becomes urgent. The venom itself is almost secondary. The Gila monster bites and chews, working venom through grooved teeth. The bite is painful but rarely fatal to humans. It's designed for deterrence. A painful bite teaches predators to avoid the bold black and orange pattern. In the desert, being left alone is as valuable as being fast. Compounds from Gila monster venom are now used in medications for type 2 diabetes. What was dangerous has become medically valuable. The Komodo dragon doesn't hunt the way most predators do. It doesn't chase, it waits. This lizard is the largest living lizard on Earth, over 10 feet long and more than 150 pounds. When a Komodo dragon bites, it doesn't go for the kill. It bites once and releases. The teeth are serrated and the bite delivers venom that prevents blood clotting and induces shock. Then the dragon follows, not closely, just within range. Hours pass, sometimes days. The prey weakens, loses blood, and eventually collapses. Only then does the dragon feed. This strategy solves a problem: energy cost.